derivatives, I can find out whether a given function is increasing or a decreasing function. So first let us discuss what is increasing and decreasing functions. So take the example, f of x is equal to x square, y is equal to x square is a function for all x belongs to the set of real numbers. The domain of the function is a set of real numbers. So I will explain graphically what is increasing and decreasing function. Okay, the geometrical meaning I will explain first. Now what you know, the graph of y is equal to x square. So it is a parabola. So this is the graph of y is equal to x square, right? So here you know how to plot the graph. So if I want to get this graph, I have to give different values for x, isn't it? So here, when x is 0, y is also 0. When x is half, suppose if I give the value of x as half, it becomes 1 by 4. When x is 1, y is also 1. When x is 3 by 2, y is 4, like this. For all the positive values, real values of x. So I get positive values of y. Now if I take the values from the other side, that is from the negative side, for the negative real numbers, if I take the values, to take x as minus 2, you get y as 4, take x as minus 1, you get y as 1 itself, because here square is there, so value of y is positive. When x is minus half, it is 1 by 4. When x is 0, y is also 0, right? So for positive real numbers, look into the graph here. If I plot the graph, when x is 0, y is also 0. When x is half, y is 1 by 4. It goes like this. See, look at the graph here. It continuously increases. So it goes up. So I call this as an increasing function. Y is equal to x square is an increasing function for the values of x is greater than or equal to 0. The same way, look into this, the other side of the graph. So when you are moving from left to right, look at that. When x is equal to minus 2, y is 4. When x is equal to minus 1, it is 1. So the graph is decreasing continuously. So here it comes down. The graph goes down. So the graph is decreasing for all the values of x. So less than or equal to 0. So here the graph is decreasing, here the graph is increasing. So I say that this side for all the values of x greater than or equal to 0, the function is an increasing function, I can say. And here the graph is decreasing. So I can say that this function is decreasing function in the interval minus infinity to 0. It's a decreasing function. So here some of the other examples if I take. See, for example, if the graph is, say, like this. This is the graph of y is equal to e to the power x. It increases continuously. So this is an increasing function. So by looking into the graph, I can say whether the function is increasing or decreasing. Suppose if it decreases, suppose I have a graph like this. It goes down completely, the graph like this, it decreases. So I can say that it is a decreasing function. Okay. So in this increasing or decreasing function, there are two categories. In increasing, one is simply increasing and another one is strictly increasing. Strictly increasing function. Two types of functions under increasing function. One is simply increasing, another one is strictly increasing. Even in the decreasing also we have the same thing, decreasing and strictly decreasing. So what is the difference between the two, increasing and strictly increasing? So I will give one example. If there is a graph of the function, suppose so look into this graph and another graph, I will take this graph itself, this one. So what is the difference between the two graphs? Look into the two graphs. See, in this graph the value increases, then there is decrease, sometimes somewhere in the some interval, then again it goes up. So variation is there somewhere, so it is not constantly increasing. Somewhere it increases, sometimes the value comes down, slows down, then again it increases. But here you see, once it starts increasing, there is no downfall at all. It increases continuously. So that is strictly increasing. So I can give you the example of your marks. In the first test you got very high mark. In the next test it is little bit less. Then the next test it increases. In the next test again it comes down. Like that it goes. So then it is increasing, I can say. Strictly increasing in the sense there is no downfall at all. Continuously, in the first test you got 70, in the next test you will get 80, in the next test you will get 90, in the next test you will get 100. So there is no downfall at all. It is increases continuously. So that is strictly increasing. Okay. Even in the decreasing also it is the same thing. When the function decreases. See, the function is decreasing. So like this it goes. So decreasing, somewhere there will be a stability or something, then again decreases. So there is no decrease in the values, there is no constant decrease. So sometimes it shows decrease, sometimes it shows some constant value, again there is decrease. See here, continuous decrease, continuous downfall in the graph. So this is strictly decreasing. This is decreasing function. This is a graph of sine function. See, there is periodic increase and decrease in the graph. See, in the first interval, half interval, the graph increases. In the next interval, it decreases. So periodic increase and decrease in the graph. Such functions are called neither increasing nor decreasing functions. Neither increasing nor decreasing. Neither increasing nor decreasing functions. So now we are going to define mathematically, so what is an increasing function and what is a decreasing function is. Can we define increasing function and decreasing function mathematically? So geometrically we have seen what is increasing function and what is decreasing function. Now the mathematical definition. So look at the definition here. Let I be the interval contained in the domain of a real valued function f, then f is said to be increasing. On I, if x1 is less than x2 in I, that implies f of x1 is less than or equal to f of x2. I will explain it once again. For all x1 comma x2 belongs to I, strictly increasing on I, if x1 is less than x2 in I, that implies f of x1 is less than f of x2. Decreasing on I, if x1 is less than x2 in I, that implies f of x1 is greater than or equal to f of x2. Strictly decreasing on I, if x1 is less than x2 in I, that implies f of x1 is greater than f of x2. So look into the difference between increasing and strictly increasing. x1 is less than x2, here also x1 is less than x2, but here you see f of x1 is less than or equal to f of x2. But in strictly increasing, the condition is f of x1 is less than f of x2. In decreasing, you see x1 is less than x2, but here the condition is look into the condition, just opposite to this, f of x1 is greater than or equal to f of x2, strictly decreasing, f of x1 is greater than f of x2. So I am going to explain this by taking one example to you. So I take the example of y is equal to x square, this is a function. So let I be the interval contained in the domain of a real valued function. See, this is a real valued function. What is the domain? Domain is set of real numbers. So I be an interval contained in that domain. So I take one interval contained in the domain. Domain is set of real numbers. In that I will consider one interval. So I consider an interval. Take the interval 2 to 6. Okay, so this is the interval I consider. Then f is said to be increasing in this interval if x1 is less than x2. So what is that x1 and x2? So in that interval, so in this interval 2 to 6, you can consider any interval. I have considered this interval. x1 and x2, those are the some points. So this is x-axis. So in this interval, I consider 2 points. I take this is x1 and this is x2. You can take any value. So I took this one as x1 and this as x2. Condition is x1 must be less than x2. So x1 is less than x2. That implies f of x1 is less than or equal to f of x2. So what is this? So this is x1 now. x1 is 3 and x2 is 5. f of x1. So what is f of x1? f of 3. So what is f of 3? So this is y is equal to f of y is equal to f of x is equal to x square. So what is f of 3? f of 3 is 3 square, that is 9. f of x2 is nothing but f of 5. So what is f of 5? It is 5 square, it is 25. So f of x1 is less than f of x2, right? So I can say that. So here it is for the condition for increasing. Strictly increasing, what is the condition? f of x1 is less than f of x2. So I got f of x1 is less than f of x2. So I can say that the given function is strictly increasing in the interval 2, 6. Of course, see, in the positive interval, the graph of that function is strictly increasing, isn't it? From the graph we have studied that. So this is how we are going to check. This is the definition. If this condition is satisfied, then I can say that the function is increasing or strictly increasing. The same way it is for decreasing. So for decreasing, what is the condition? So in the given interval, x1 is less than x2. Suppose if I consider this. In the given interval, I -4 to -1. This is the interval I consider. So in the interval, I will take this as x1 and this as x2. So condition for decreasing, x1 is less than x2 such that f of x1. So what is f of x1? f of x1 is f of -3. What is f of -3? I get 9. f of x2, that is f of -2. What I get? I get 4. So f of x1 is greater than f of x2, right? So decreasing functions condition, x1 is less than x2, f of x1 is greater than f of x2. See, f of x1 is greater than f of x2. So I can say that this function is strictly decreasing. So this is the definition of increasing and decreasing function. By looking into the graph, easily you can make out whether the function is increasing or decreasing. Okay, there is a theorem here. By using this theorem, easily, mathematically, I can find out whether the function is increasing function or decreasing function. Okay, without drawing or without looking at its graph. So look at the theorem here. So theorem states that let f be a continuous function in the closed interval a comma b and differentiable in the open interval a comma b. So there is a function given to you, you know that, which is a continuous function and it is a differentiable function. Then the function is strictly increasing in that given interval if f dash of x is greater than 0 for each x belongs to that interval a comma b. F is strictly decreasing in the given interval if f dash of x is less than 0 and f is a constant function if f dash of x is equal to 0. So I will explain all these three with the example and then we will go to the proof of this. Okay. So first I will explain this. F is strictly increasing if f dash of x is greater than 0. Why this condition? F dash of x is greater than 0. See, I take the same example of f of x is equal to x square. F is a continuous function on the closed interval a comma b. So what is that a comma b? So it is some interval here. For example, if this is 1, 2, 3, 4 like this. So in this interval, so I take this as a and this as b. Okay. So in this interval, the function is continuous, it should be continuous. Of course, the function is continuous, there is no break in the graph and it is also differentiable. Then f is strictly increasing in that interval. In this interval, I can say that the function is strictly increasing if this condition is satisfied, f dash of x greater than 0. So what is the geometrical meaning of that f dash of x greater than 0? So we know that f dash of x is nothing but dy by dx. So dy by dx is nothing but the slope of the tangent at that given point. Slope of the tangent, f dash of x is greater than 0 for each x belongs to that interval a comma b. So in this interval, open interval it is a comma b. In this interval, whatever may be the point you take. See, for example, at the point 2 here, this is the point. At this point, I will draw a tangent to this graph. I will draw the tangent. F dash of x is nothing but a tangent, slope of the tangent. So here this is angle theta. So what is the slope? Slope is nothing but a tan theta, where theta is the inclination. See here theta is acute. So tan theta is always positive. Theta is acute, tan theta is positive. So slope is positive. F dash of x, slope is nothing but f dash of x. F dash of x is positive. That is greater than 0. That is the meaning. So here this is possible only when the graph goes up, it increases. So for each x belongs to that open interval a comma b. Any point you take in this interval, any real number you take in this interval, that condition has to be satisfied. Slope is always positive. Of course, it is true for any point. Any point you take and you draw the tangent, your theta is always an acute angle. So tan theta is positive. So f dash of x comes out to be greater than 0. Then I can say that the function is increasing. This is the geometrical explanation I have given. So when the problem is given to you, you have to just check f dash of x. Your f of x will be given to you. You have to find out f dash of x. That means you have to differentiate that function. Whether that function is greater than 0 or not, you have to check. If it's greater than 0, then I can say that the function is strictly increasing. For strictly decreasing, so what is the condition for strictly decreasing? F dash of x is less than 0. F dash of x is less than 0. So how it is, we will see. The same function when I take. So in the given interval, so this is A and this is B I take. Okay, in the given interval A comma B, suppose at a particular point, at this point suppose, I draw a tangent. I draw a tangent to this graph. So look at the inclination here. So this is the inclination. Inclination is always, this is theta, inclination. It is the angle made by the line in the positive direction of x-axis. That is inclination. So this is theta. So theta is obtuse here. When theta is obtuse, slope is tan theta. When theta is obtuse, tan is always negative. So slope comes out to be negative. So f dash of x is less than 0. That is the geometrical meaning. So when the function is said to be strictly decreasing, f dash of x is less than 0. Then I can say that the function is strictly decreasing. Next, third condition is when f dash of x is equal to 0, then it is a constant function. Of course, if suppose there is a constant function y is equal to, or f of x is equal to 4, this is a constant function. So what is f dash of x? It is 0. So f dash of constant function, see here y is equal to 4. So how the graph is? Y is equal to 4. So this is the graph. Y is equal to 4. Suppose this is 4 here. That is the graph, isn't it? So of course it is a line which is parallel to x-axis. So slope of any line parallel to x-axis is always 0. So if f dash of x is equal to 0, then we can conclude that it is a constant function. So then what about, so here we have talked about strictly increasing and strictly decreasing. What about increasing and decreasing? Of course, if a function is strictly increasing and strictly decreasing, then I can say that it is in the given interval, it is an increasing function or decreasing function. But the converse is not true. If the function is strictly increasing, then I can say that it is increasing. Or if the function is strictly decreasing, then it is in the given interval, it is decreasing. But it is, if the function is increasing, then I cannot say that it is strictly increasing. Converse is not true. So here we have proved that the function is strictly increasing or strictly decreasing. So I can say that the function is increasing or decreasing in the given interval. We are going to prove this theorem. First I will prove it for the first one. F is strictly increasing in the closed interval a comma b if f dash of x is greater than 0. Okay. Let x1 comma x2 belongs to the closed interval a comma b. This means I am considering 2 points in the given interval a comma b. So I am considering it as x1 comma x2. I have explained you with a particular example. Now I am generalizing it such that x1 is less than x2. Now see here, by mean value theorem, Lagrange's mean value theorem we have studied in the previous lesson, that is continuity and differentiability. There we have studied the mean value theorem. So in that Lagrange's mean value theorem, so if there are 2 points x1 and x2 in the given interval a comma b, then there exists a point c such that f dash of c is equal to f of b minus f of a divided by b minus a. So we had this definition. So I am applying that Lagrange's mean value theorem. By mean value theorem, f dash of c is equal to f of x2 minus f of x1 divided by x2 minus x1. So this is a, this is b. According to, in the mean value theorem we take it as f of b minus f of a divided by b minus a. Here I have written in terms of x1 and x2, f of x2 minus f of x1 divided by x2 minus x1. So now here if I cross multiply this, so I get f of x2 minus f of x1 is equal to f dash of c into x2 minus x1. But it is given that f dash of x is greater than 0. That is f dash of c is greater than 0. So x is nothing but here this x and c. So it is one particular, this C is one particular value in the given interval a comma b. So it is given that f dash of x is greater than 0. So I can consider that f dash of C is greater than 0. Since f dash of C is greater than 0, this quantity also comes out to be greater than 0, because x1 is less than x2. So x2 minus x1 is also positive quantity. This is also positive quantity. Hence f of x2 minus f of x1 is greater than 0. So f of x2 is greater than f of x1, or I can say that f of x1 is less than f of x2. See, I considered that x1 is less than x2 and I proved that f of x1 is less than f of x2 according to the definition of strictly increasing function. So what is that strictly increasing function? Says if x1 is less than x2 in the given interval, that implies f of x1 is less than f of x2, then I can say that the function is strictly increasing. So I proved, I have considered x1 is less than x2 and I proved that f of x1 is less than f of x2. Hence I can say that the function is strictly increasing in the given interval. The proof is similar to the other two also, decreasing function and for the constant function the same proof you can apply. Problems from exercise 6.2 which are based on strictly increasing and strictly decreasing functions. Look at the first question here. Show that the function f of x is equal to 3x plus 17 is strictly increasing on the set of real numbers. So what is the condition for strictly increasing? Look at the theorem. A function is strictly increasing if f dash of x is greater than 0. So here f of x is given. F dash of x I will find out. So what is f dash of x? Derivative of 3x is 3, derivative of 17 is 0 in here. So f dash of x is 3. Of course it is greater than 0 for all x belongs to R. Hence f of x is strictly increasing. This is it. So you have to prove that condition, f dash of x must be greater than 0 for all the values of x in the set of real numbers. Hence it is strictly increasing. Look at the next question. The function f of x is equal to e to the power 2x is strictly increasing. I have to show that that function is strictly increasing. Of course the same thing, f dash of x you have to find out. F dash of x, it is e to the power 2x, derivative of 2x is 2. So it is 2 into e to the power 2x. See, this is for x is greater than 0 for all the positive values of x. 2 into e to the power some positive quantity. E to the power some positive quantity is a positive quantity, because e to the power x or e to the power ax, it is always a positive quantity. It will not give any negative values, because the range of exponential function is positive real numbers, we know that. For x is greater than 0, f dash of x is greater than 0. When x is equal to 0, when x is equal to 0, when I substitute x as 0, here you will get e to the power 0, it is 1. So you will get f dash of x is 2, which is greater than 0. So when x is less than 0, negative values. So here whatever may be the value of x, whether it is positive or negative, e to the power x is always positive value. So f dash of x is greater than 0. Hence for all the values of x belongs to R, the given function is f dash of x is greater than 0. Hence the given function is increasing function. For all x belongs to R, f dash of x is greater than 0. Hence f of x is strictly increasing function. The next question, show that the function given by f of x is equal to sin x is strictly increasing in the open interval 0 to pi by 2 and strictly decreasing in the interval open interval pi by 2 to pi, neither increasing nor decreasing in the interval 0 to pi. See, by looking into the graph of sin x, easily you can make out. See, 0 to pi by 2, it is increasing, then pi by 2 to pi, it is decreasing, right? So this is from the graph. Now we have to prove it. So f of x is equal to sin x, it is given. So f dash of x I will find out. F dash of x. Derivative of sin x is cos x. Now the first question. The function is strictly increasing in the interval 0 to pi by 2. So strictly increasing, what is the condition for strictly increasing? F dash of x is greater than 0. See, in the interval 0 to pi by 2, that is in the first quadrant. In the first quadrant, I got f dash of x is cos x. We know that in the first quadrant cos x is positive. Hence, f dash of x is greater than 0. So, in the interval 0 to pi by 2, f dash of x is equal to cos x is greater than 0. Hence, the function is strictly increasing. B. Strictly decreasing in the interval pi by 2 to pi. Pi by 2 to pi is in the second quadrant. So, in the second quadrant, f dash of x is cos x. In the second quadrant, cos x is negative. So, f dash of x is negative. F dash of x is negative is less than 0. So, in the interval pi by 2 to pi, f dash of x is cos x, which is less than 0 in the second quadrant. In the second quadrant, cos x is negative, less than 0. Hence, the function is strictly decreasing. Third one, neither increasing nor decreasing in the interval 0 to pi. So, as I said, when there is periodic increase and periodic decrease, the function increases and decreases periodically, then such a function is called neither increasing nor decreasing. So, here in the interval 0 to pi by 2, the function is increasing. In the interval pi by 2 to pi, the function is decreasing. So, it is periodic change. Hence, I can say that the function is neither increasing nor decreasing in the interval 0 to pi. So, in the same way you have to write, in the interval 0 to pi by 2, f of x is increasing. In the interval pi by 2 to pi, the function is decreasing. Hence, the function is neither increasing nor decreasing in the interval 0 to pi. Look into this question. Find the intervals in which the function f is given by f of x is equal to 2x square minus 3x is strictly increasing and strictly decreasing. So, here it is not asked to check the function is increasing or decreasing. They did not ask you. They asked you to find out the intervals, in which interval the function is strictly increasing and in which interval the function is strictly decreasing. So, here I have to find out those points on the x-axis where it is strictly increasing and where the function is strictly decreasing. So, what I have to do to find out the intervals? So, what I do is I take the function f of x is equal to 2x square minus 3x, f dash of x. So, f dash of x is 4x minus 3. Say I equate this f dash of x is equal to 0, f dash of x is equal to 0. So, why I am equating this to 0? So, in this Rolle's theorem and Lagrange's mean value theorem we have studied. So, there whether when the function is increasing or decreasing, to find out that critical point f dash of c is equal to 0, there exists some point c where f dash of c is equal to 0. So, to find out that critical point, I am going to find out that critical point. See, in this graph of y is equal to x square, See, in this interval it is increasing and in this interval it is decreasing. So here there is a critical point. So I get a trough, isn't it? I get a trough decreasing and then it is increasing. So there I get a trough. This is a point, a peak point I get. So I have to find out such a point here, that critical point I have to find out. So to find out the critical point, I am equating that f dash of x is equal to 0. So f dash of x is equal to 0, that is 4x minus 3 is equal to 0. 4x is equal to 3, x is equal to 3 by 4. So I got one point, x is equal to 3 by 4. So that is the critical point. Okay. This point x is equal to 3 by 4 divides the intervals. One is from minus infinity to 3 by 4, another is 3 by 4 to plus infinity. So now in these two intervals, in which interval the function is strictly increasing and in which interval the function is strictly decreasing, I have to find out. So what you can do, how you will do it? If you want, you can make a table like this, otherwise it's okay. So here if I write, this is an interval, which interval? Two intervals I get, minus infinity to 3 by 4 and 3 by 4 to plus infinity. So here the procedure is same, f dash of x, if it is strictly increasing, f dash of x is greater than 0, if it is strictly decreasing, f dash of x is less than 0. So in this interval, f dash of x is greater than 0 or less than 0, how to find out? So what I do is, in this interval, take any one point, in between minus infinity to 3 by 4. I take one point, I substitute it in f dash of x. For example, take one point as minus 1, here I get minus 1. So if I take f dash of minus 1, what is f dash of minus 1? 4 into minus 1, it is minus 4 minus 3, you will get minus 7. So it is negative. F dash of x is negative. Any point you can take in this interval, it is not only minus 1, it should be true for all the points. Whatever the points you take in the open interval, you get f dash of x is negative. In the same way, you check in this interval, 3 by 4 to plus infinity, take any one point, you take some easy points. See, 3 by 4 means I can take a point 1 here. So f dash of 1, 4 into 1, it is 4 minus 3, you will get 1. So it is positive. So in this interval, f dash of x is positive. So f dash of x is negative in this interval and positive in the other interval. So in which interval it is strictly increasing? In the interval, open interval 3 by 4 to infinity, the function is strictly increasing, and in the interval minus infinity to 3 by 4, the function is strictly decreasing. That is your conclusion. So you have to write that conclusion. You have to write this number line. This is optional. If you want, you can write it. Otherwise, you can just write this number line and you write negative and positive over that. That is sufficient. So you have to prove that y is equal to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function in the interval, closed interval 0 to pi by 2, that is in the first quadrant. So what I have to do is, so first I have to find out f dash of x, that is y dash. So here it is quotient rule I have to use. Derivative of 4 sin theta is 4 into cos theta minus derivative of 2 plus cos theta, derivative of 2 is 0, derivative of cos theta is minus sin theta, minus derivative of theta with respect to theta, it is 1. So actually we are differentiating with respect to theta because the function is in terms of theta. So this is equal to, simplify this, So I can take the LCM 2 plus cos theta whole square. Here 4 is common, cos square theta plus sin square theta minus so when I simplify this further, cos square theta plus sin square theta is 1, 8 cos theta plus 4. Here this I have to expand by using a plus b whole square formula. A square so it here 8 cos theta minus 4 cos theta is 4 cos theta. So this is y dash. Now you have to decide whether y dash is greater than 0 or less than 0 by looking into this expression. So how to decide by looking into this expression whether it is greater than 0 or less than 0. So here in the interval 0 to pi by 2, that means in the closed interval it is in the first quadrant. In the first quadrant cos theta is positive. So this is a positive quantity then. So when I give any value for theta, here I get a positive quantity. This 2 plus cos theta. So in the first quadrant I get a positive value here. Anyhow it is square is there, so denominator is positive. So now we have to look into this term 4 minus cos theta. See in the first quadrant we know that for any value of theta, the value of cos theta toggles between minus 1 to plus 1. Minus 1 to plus 1. So this is 4, here the value is in between minus 1 to plus 1. Of course it is a positive, 4 minus something in between minus 1 to plus 1. This is a positive quantity. So the whole expression I get a positive quantity. It is greater than, it may be equal to 0 when, since it is closed interval, cos 90. Cos 90 is 0, 0 into something, the whole thing will become 0. It may be equal to 0 also. So y dash is greater than or equal to 0. Hence I can say that the function is increasing function. For strictly increasing, f dash of x is greater than 0. If f dash of x is greater than or equal to 0 if it comes, then I can say that it is an increasing function. Here it is strictly increasing, here it is an increasing function. So f dash of x is greater than or equal to 0 I get. So hence it is an increasing function. So that the function f given by f of x is equal to x square minus x plus 1 is neither strictly increasing nor strictly decreasing in the interval minus 1 to 1. F dash of x I find out. So f dash of x is 2x minus 1. So if I equate f dash of x to 0, I get x is equal to half. The interval minus 1 to 1, the function is neither increasing nor decreasing. So in that interval minus 1 to plus 1, here x is equal to half I got. Now in this interval minus 1 to half, minus 1 to half. Take one point, I take a point 0 here, isn't it? So f dash of 0. So what you will get? F dash of 0 will get minus 1. So it is negative. In this interval, half to 1, you can take 3 by 4. So if I take 3 by 4 here, I will get 6 by 4 minus 1. Of course, it is a positive quantity. It is a positive quantity. See, minus 1 to half, it is decreasing. Half to 1, it is increasing. Periodic it is. See the gap. What do you mean by periodic? That gap must be same. Minus 1 to half, same gap. Half to 1, the gap is same. Periodic change it is. Whenever that is, when the function is periodically increases and decreases, such a function is called neither increasing nor decreasing. So you have to write in the interval minus 1 to half, the function is decreasing, and half to 1, the function is increasing. Increasing, decreasing, increasing. This is the symbol you can use, decreasing function and increasing function. Hence, in the interval minus 1 to 1, the function is neither increasing nor decreasing. This is your conclusion.